All right, so for the next part of our data analysis, we're going to address outliers and unusual values. So we did all this work where we determined, we didn't fully determine, but we're getting closer to determining whether our data sets or variables are independent or dependent. So if it's dependent, then you would want to use a correlation technique. So when I say likely dependent here, it gets me thinking that it's going to be one of these possibilities, one of these tabs that we already created. If it were independent, then there's something else that we can do that'll be the subject of another activity that we do down the line. Right? The simplest way I think to account for the outliers and unusual values would be to go into one of our old activities in Schoology. It was in Unit 1, outliers and unusual values. And we'll actually go to either solved examples or the work that you did in the assignment either way. Right? If you scroll down, you see that we have 5-number summary, outliers, unusual values over here. So I'm just going to do a copy paste. We'll have to change up, I mean, obviously the actual outliers of Kazakhstan and China and all that, those won't be relevant, so I'm not going to copy that stuff. But I'll copy this, bring it over, and I'll paste it in. All right, so I'll do it like right here. All right. You see there's no reference values, and we get a 2 here for some reason. We'll address that in a minute, but what I'll do is I'll grab these values also, or this information. Summary statistics, sample mean, sample standard deviation, all the way down. Again, we don't need the actual countries because that's not necessarily relevant to what you're working on. All right, so I'll put that down over here. All right, so it says reference doesn't exist because it's the min of what? Well, I'm looking at the high temperature column. Mine goes from B2 down to B184. Yours definitely doesn't necessarily go down that far. Right, so to account for that, you do B2 colon B. It'll go right on down to the end of the line. If you're using Excel, for some reason it flips out when you try doing that, so you'll have to put a hard cap on it. So I think mine was 182, so I do B2 colon B 182. So my Q1, same deal, B2 to B. I'm just going to copy that. Same thing with the median. You know, you might say, well, why not just do this straight from scratch? At least we have the commands in here, and it's a matter of just updating references. So that's kind of why I tend to do it this way. And all along, these activities were kind of piecemeal way of doing these sort of calculations, where we did it for other instances earlier, but now we can apply it to our own data. And when we change the data set, all this stuff will change along with it. So it's pretty useful. It ends up being kind of a user-friendly calculator, almost like a universal one. All right. So this references the right stuff. Q3, Q1. My low bound for my non-outliers. Make sure it's referencing Q1 minus 1.5 times my IQR. We're good to go there. High bound, Q3 plus 1.5 the IQR, so we're good there. Number of outliers. We need to update our references here. Says that there's none. So at this point there are none, but if you add more data down the line, it may change. So we'll keep that in mind. Sample mean, G3 to G38. I highly doubt that. All right, so we're looking at B2, still B2 to B. All right, so we'll update our references here. B2 to B, lock it in. And again, if you're using Excel, it's B2 to B, whatever your max row reference is. All right, low bound, let's see if it's referencing the right things. So mean minus 2 times the standard deviation, good. Yep. Mean plus 2 times the standard deviation, which is in 43, good. Number of unusual values, it's not referencing the right stuff, so we have to make that adjustment. Looks like I have 10 unusual values, so I'm going to have to go and hunt around for those. right? So anything that's less than 27.3-ish and greater than 73.256-ish. Now, you can do this now, but I would recommend actually holding off on this until you get more data values in there. You'll see I noted on November 7th of last year that we might have had a possible outlier. Actually, I didn't note this. Another student had collected this data over the course of last year and noted that this was a possible outlier, but it does not seem to be one based off of our calculations. All right. So now in that interval, like if we were just looking at daily high temperatures in November, maybe it's an outlier compared to the other temperatures in that month, but throughout the course of this study, it turns out it's not an outlier. But we do have several unusual values, so we would want to account for that. But like I said, hold off on that until we get closer to the end of the semester, because then you'll have the most data, and this number might change. It might turn out that there's like only 2, and you would have had to hunt through and find 10 of them when 8 of them aren't relevant. All right, so hold off on that. But we also need to do this for our low temperatures. So what I'm going to do here is grab this and drag it over and see if it updates the way I want it to. Everything should be referencing C now, and it looks like so far so good. Yep. We're in H. Yep. Low bound, pointing to the right stuff. IQR's in 31, good. Double checking here. 28, yep, 31, good. Same idea. We have outliers potentially. All right, so what we're going to want to do, and make sure this is pointing to the right stuff too. We're going to want to hold off on that because that might change depending on more data that you collect. Now, my data is not going to get updated, so I could actually go through and figure out what the outliers are and the unusual values. But I would say, again, don't do it just yet. But when you do get to the point where you want to do it, what I would do, instead of writing a line command to do this, which is fine, you could do that, I would just copy my data over somewhere kind of on the side here. All right. You could just do a normal copy paste, but I like to do values only just to be safe. Then put it in order. So sort range A to Z. All right. So again, you have all your data, sort range A to Z. All right. And then I'm looking for, so I'm not looking for in my first data set any outliers, but I'm looking for 10 unusual values. So I'd say, do I have anything that's below 27 and change, 27.3 repeated? Not repeated, I don't know what I'm saying there. So I have 2 of them, 23 and 26. And then on the high end, anything more than 73.25-ish. So 73, let's get to the 70s. 73.25-ish, so that's all these values here. All right, so, I'll just do it this way. Actually, let me move it down. I'll put the 23 here, the 26 here, and then I'll highlight to get it all in the same cluster there. And, so that's for your B column, so I'll do the same thing for my C column. And again, can't emphasize this enough, you don't have to do this now. Once you've collected or you've finished collecting all of your data, that's when you would do this. All right, but I just wanted to have it somewhere so that you were ready to go with it when the time came. All right, so arrange it in order. So it's in order. What we're looking for in this column is 3 outliers. The low bound is 7.5, so that's not anything we need to worry about here. I'm looking for anything bigger than 59.5. There should be 3 of them, so that should be on the high end. 59.5 would be in between these 2 numbers, so 60, 61, and 62. So I'll just pop that in here. I'll use commas. Only 3 values, not too bad. If there were more than that, then I would consider doing what I did before and just kind of expand it and give each one their own cell. Right? For the unusuals, there's 12 of them. On the low end, 14.08, so that 13 is going to be one of them. Actually, the 14s would be also. So pop those in there. Then on the high end, anything bigger than 54.54. So 54.54 would allow for us to grab these values, I guess. And just make sure there's 12 of them. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we got all of them. Highlight it. And those are our values. Then what I would do is spend some time kind of cleaning things up a little bit. All right, so I'll get rid of that. Maybe I'll center some things here. All right, these are all related to the same variables. So I'll put a little bold face on that. Maybe space it out a little bit. It's really up to you. It's more of a style thing. You just want it to be as readable as possible. All right, so then going down the line here, well, this one I'll offset to the right a little bit, or I'll just right justify it. That's what I'll do. Then these I can center. Same thing with these, and I'll do that down the line here too. Remember, Command Y, it repeats the previous action. So once I selected center, I could just hit Command Y when I highlight things. All right, maybe I'll do it for these two. Yeah, why not, right? All right, and so that would be a summary kind of worksheet, I guess, that would allow you to start to begin to draw conclusions. So between the linear, exponential, quadratic, and logarithmic transformations and all of this stuff, you should be able to start parsing through your data and figuring out what's really going on. But I'll guide you through that as we go. The difference, or the important distinction here, is whether or not there is a relationship between the two variables. If it's likely that they're dependent, then we work with these tabs. If they're independent, then that'll be the subject of our next activity. All right, so for now, this is all you really need to do. And we're going to create some graphs for each individual column of data, but that's for another activity down the line.